Something like something that's connected to a wall plug where measures are taken to limit transient over voltages. Something like a copier, high voltage section of a copier. How many work on copiers? Well, electronic air cleaners. There you go, same thing. High voltage section of electronic air cleaner qualifies as category 1. Anybody have any idea what a Honeywell F50 air cleaner puts out voltage-wise on the plates? About 6,000 volts. Yeah, but that's just a category 1. The level of hazard is actually quite low. It's there. You ever hear those air cleaners snapping and popping? No. That's high voltage right there, buddy. We're talking about the relationship between voltage and current and how it affects us and how it affects the circuits we work on too. So when you hear 6,000 volts, you're like, wow, that's a lot of voltage. Sounds dangerous. I tell you what, from a working solar, a 24-volt battery circuit will kill you deader than nothing. The 6,000-volt electronic air cleaner is just going to make your hair stand up a little bit. It ain't going to do nothing to you. Category 2, single-phase receptacle connected loads. Anything plugged into the wall, boom, right there. Those are category 2. And working inside of this TP, that'd be category 2. Inside of that receiver, category 2. Inside of a power tool, cat 2. Anything plugged into the wall. Your humidifiers, those humidifiers we're talking about on Monday, cat 1, cat 2. Category 3, now this is where we get a little higher D. 3-phase distribution, which would be distribution in the panel, like that one, including single-phase commercial lighting. You guys do any commercial work at all?
Not the HVAC.
Where we're concerned with single-phase commercial lighting is if you're working above a drop ceiling.
Above what?
Above a drop ceiling in a commercial building. Working above a drop ceiling. So you've got ceiling tile removed, you're up there working, maybe there might be an electric water heater above the ceiling on a mezzanine, there might be pipes up there, there might be ducts up there, there might be zone valves up there. You're up there. There's also commercial fluorescent lighting up there. And that stuff often is going to run on 277 volts AC, depending on what type of building you're in. 277 is high dangerous voltage, and those lighting fixtures are often maintained by what I would consider unqualified personnel. Building maintenance, facilities maintenance people that don't necessarily understand some of the safety precautions necessary. So if you go up above the drop ceiling in a commercial building and you look around very carefully, it's not uncommon to see someone replace the ballast on a lighting fixture and there's just wires just hanging out there. That could be deadly lethal voltage right there. Especially if one of those wire nuts accidentally pops off and it happens to stab you in the back and you're up here doing something else. So bring this up so when you're in this environment, get your flashlight out and take a look around. Show us nothing just waiting to wake you up or put you to sleep. This includes equipment and fixed installations such as switchgear and polyphase motors. Polyphase would be 3-phase. Bus and feeder in industrial plants. Feeders and short branch circuits. Appliance outlets with short connections to the service entrance. This is where we're concerned right here. If we're in a mechanical room, either in a home or a building, and it's in this room right here, which is not uncommon, we are very close to the service entrance, and this is a higher risk category than if we were working on the exact same type of appliance on the other end of the building. You've got to pay attention to where you are proximity-wise. Category 4, this is the 3-phase utility connection in any outdoor conductor. That means between here and here, which we're not going to be working on. Meters are rated for these different categories. And it's going to be listed right on the meter. Look at your meter in this vicinity, usually near the plug, and see what category level you're at. It's going to give you a cat rating plus a voltage rating. Cat 3. Who does not have a meter with them right now? On here, do you have a meter? You need one? Everybody raise your hand that doesn't have one. You all need to have one. 1, 2. All right. Come on up here. Borrowed. Does anyone have something less than cat 3? Good. You got a cat 2? Let me see what you got. Get 2. I don't recommend using anything less than a cat 3 for any in-home service work. You want to have a cat 3?
I got a question. So the one over there that I was looking at says cat 2, cat 1, cat 3 on it.
still good for Cat 1 or?
Yes. Yes, the higher the rating is good for everything underneath that. So my meter is rated at Cat 3 for 1,000 volts, Cat 4 for 600 volts. So you get a Cat rating plus a voltage rating combined. So your Cat 2, Cat 1, Cat 2, or Cat 2, Cat 3 is going to be probably Cat 2 at 1,000 volts, Cat 3 at 600 or something like that. Your test leads also have Cat ratings on them. So when you're buying replacement test leads, you want to pay attention to the Cat rating on them. Cheaper is not better when it comes to test leads. Everything that plugs into your meter should have a CAT rating on it somewhere.
Yeah. Cat 3 and Cat 4.
This one here is also, this one's 1,000 volts at Cat 3 and 600 volts at Cat 4, 1,000 volts at Cat 2. By the way, working with power tools, little side note. Have you ever seen that symbol on a electric power tool? That's what that means. It's called double insulated. What that symbol means is that if you are sawing into a wall with a sawzall, for example, or any other kind of power tool, drill, whatever it has, and it's double insulated, and you hit a live line, you're less likely to be electrocuted if you're using a double insulated tool. So pay attention to that as well.
So some of my leads here have the deal that you pull off.
Yeah.
So this set here, which is the field piece set, it says Cat 2 with this off. Cat 3, Cat 4 if that's on.
Yep. So can I borrow that and pull that up for everyone?
Yeah,
A couple of, this is a field piece feature where these little shrouds, these are called tip shrouds. There's only a very small amount, about 3/32 of an inch of bare metal exposed on the end. And this one has a good 1/2 inch, 5/8 of exposed metal on the end. That's the difference of category. It's how physically close are you to the source of energy, and also on higher voltage pitches can jump. When you're working on testing live circuits, you're probing with the end of the probe, but if you're in a crowded electrical compartment and you've got other live terminals around, and you angle your meter or your tip, you can actually bridge two terminals together.
Cause
Cause a short between them, which is going to be an arc flash. If you're doing it right in front of your face, that's a bad deal. So these chip shrouds are there to help protect against that, and you get a higher level of safety rating on that meter as a result, or on that lead as a result.
And a new meter?
Huh?
You're going to need a new meter as well?
No, you won't need a new meter, but if you do that, you'll burn the end of your tip off. Good chance of that. Now on mine, I've got a slightly different arrangement. Let's see if I got it right or not. I've got a modular test lead set up, so I can put different ends on my test leads, which I think is really cool. I want to pass these around. This would be a standard lead, this would be a shrouded tip. Any questions about meter safety? Let's talk about the effect of electricity on the body. Now this comes into electrocution versus electric shock. There's a difference between electrocution and electric shock. When you get an electric shock, it's usually very brief, and what happens to your body when you get an electric shock?
Your whole arm feels
Yeah. Boom! Just jerk, right?
elbows hurt.
Yeah, your elbows hurt. Boy, I tell you what, if you get a decent shot, every joint in your body hurts. The next day, it's like you got hit by a car. You're like, what the heck? Oh yeah, that's right. I got tickled the other day.
Oh, idiot.
It's been 8 days, my hand still feels it.
Really? Wow. Yes. Yeah. Remember when we talked about some people were saying biological energy or chemical energy? Your bodies are electrical power plants. You're actually converting the food that you eat into electricity. And those electrical impulses are what cause your muscles to move. When those electrical impulses are artificially applied from some other power source, your muscles will still move. But there's going to be a lot more power than you're putting out. You're going to move in a very big, strong, jerky way. You can literally rip the muscles right off of your bones. I knew somebody that happened to me. That's not cool. More importantly, when you're working on lower voltages, you get that jerk, generally your elbows go back. And whatever behind you, you break your arm. You're on a ladder, you fall off. You're on a roof, you fall off. You're more in danger of a physical impact injury due to electric shock than you are actually electrocution. So be aware of that. That the hazard is real. You can be really badly hurt, not just from electrocution. But when we're talking about electrocution, how much current does it take to cause pain? Because it's really a combination of voltage and current that is the danger zone. The current is really what we respond to. Now, when we refer to a milliamp, milli is a prefix. We'll talk more about this later. Milli, M-I-L-L, means 1/1000th of something. 1/1000th is 1 milliamp. 1/1000th of an amp. When you experience that, you'll just get a little bit of tingle, a little bit of tickle. At 5 milliamps, that is a shock. It'll be disturbing, but not necessarily painful. Most people can let go of that. However, strong involuntary movements can cause injury. That's the jerking I was talking about. Between 6 and 30 milliamps, depending on a couple of things. How much water you drink, and what your gender is, how physically large you are, things like that. That's why there's a difference between men and women. This is a painful shock. Muscular control is lost. This is the range where freezing currents start. It may not be possible to let go because that electrical impulse is causing your muscles to tense up, and there's nothing you can do about it. You'll just be locked on it. Now, for some reference, this is 30,000ths of an amp. A standard 60-watt light bulb, for those of you who remember 60-watt light bulbs, the 60-watt light bulb is 500,000ths of an amp. So this is 30,000ths of an amp versus 500,000ths. Just a small fraction of the energy it takes to illuminate the single light bulb that's in your drop light. Not a whole lot of power is required to cause injury. Between 50 and 150 milliamps, this is where your breathing stops. That's pretty significant. That's not a whole lot of power, actually. And this level of amperage can happen at any level of voltages above 50 volts. So voltage is really the thing. Between 1,000 and 4,300, and this is 1 to 4 amps. This is about your anywhere between your furnace draft reducer motor and the blower motor on a smaller unit. Heart will not work. You're done. You're done. You did. 10 amps. That's when, like, you become actually an electric heater inside. So how do we protect ourselves against this? It's just like having firearms. Mark, what is the first rule of firearm safety?
Keep your finger out the trigger until you're in the pole.
All right. So if I hand you a weapon, what's the first thing you're going to do?
Treat every gun as if it's loaded.
Thank you. Absolutely. Treat every firearm as if it's loaded. Even if you know darn well that it's not loaded, it's just a good habit to get into to act as if it is. Right? You're going to point it in a safe location. You're not going to do ha 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 ha, right? Tee hee hee. Not going to do
Mine
that.
is loaded.
This is why I speak because of sound.
Treat every electrical wire as if it's energized. I would much prefer to handle a conductor with something other than my fingers. I'm going to grab hold of wires with a tool, preferably rather than my fingers. Now this is not an insulated tool. And in fact it says right on it, it says, warning, not insulated, will not protect against electric shock. 1 second. You can buy insulated tools which are at least double if not triple the money of a regular tool. But even so, you can at least have some measure of safety better than grabbing the darn thing with your fingers. In addition to that, if I'm going to grab a conductor, even if I know that it is dead, I'm going to grab it back here. I'm not going to touch the copper part just because I can tend to forget things. You ever forget anything? I left my cell phone in the bathroom at the grocery store yesterday.
My wife was like,
Fortunately, I got